Welcome to the Real Python Podcast. This is episode 161. Are you looking to advance your CircuitPython projects? Would you like a collection of resources and tools to help you along your path? This week on the show, Tod Kurt is here to discuss building projects with CircuitPython. Tod has been working with embedded electronics for a long time and has been an active member of the Arduino community. He recently started to build projects using CircuitPython, and it's become his preferred prototype method. He shares software resources, hardware tools, and advice about working with CircuitPython and embedded electronics. We discuss several of his music hardware projects and the libraries and modules for synthesis. He also shares a powerful online prototyping tool to plan your project before spending money or plugging in a soldering iron. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Tod, welcome to the show.
Hi, thanks for having me on.
Yeah, I was very excited to talk to you about CircuitPython and all the projects that you do. I have bought several of them.
Oh, thank you.
Yeah, and I wanted to just kind of a little bit nerd out about CircuitPython, but also get some advice for people that are maybe going beyond some of the basics. Like I've had a couple of people on in the past to talk about some of the fundamentals of, getting started with CircuitPython, but I think of what are the next level? What are some advanced projects and kind of fun things that you can do with it? And a lot of the listeners already know that I'm really into music, and you kind of have that bent in a lot of the projects you do.
Yep.
Anyway, maybe we could just briefly talk a little bit about yourself. You founded a company called ThingM. Can you tell me a little bit about that?
Yeah, sure. So imagine a world before the Internet of Things. So around 2006 or 7, me and my business partner, Mike, we were trying to evangelize what we were calling ubiquitous computing. There's like a term of art at the time in academia. And we were trying to just get people to think like companies mostly, because we were trying to be contract engineers or design products.
Yeah.
Imagine a world where like previously dumb objects could be on the internet and could talk to each other. Like imagine a internet connected toaster or an internet connected dresser. What would they say to each other? And so a lot of it was kind of funny in retrospect, because
Right.
The Internet of Things nowadays I kind of distance myself from, because it's gotten a little useless.
Now that all those appliances are online.
Yeah. No, I mean, it's unfortunate, because we were imagining a world more like the original internet, where everything was sort of a citizen of themselves or a citizen of your house. But these internet connected devices now, they're really citizens of a company that you rent time on. And so like when you have your internet connected refrigerator, you don't fully control that system that's on your fridge. It's connected to some server, like Samsung server or whatever. And so the Internet of Things that exists today, I think, is a very broken one, because it's mostly, it mostly lives outside of your house.
Yeah.
And for things that are just purely in your house. And if you have a smart light bulb and you click the button to turn on the smart light bulb, it actually goes through like Amazon servers before it turns on the light. It's like, why? It should just connect directly over your local LAN. So anyway, that was the original premise of ThingM, was like, let's make devices that are smart. Take previously dumb things, make them smart, see what happens, find some cool new use cases. We had a hard time finding cool new use cases, as we've seen now, as people have tried for like 15 years. But out of the research from doing that, one of the things that came out was the Blinkum little I2C LED, and this was like in 2007 or 8, that was for Arduinos. And that became very popular. It was back in the day, it was really hard to control RGB LEDs with Arduino. So here is an easy way using the I2C serial protocol. You just kind of plug it in, send it some commands, and it could be whatever color you want. You can even store color patterns on it. And then I took that idea and made a USB version, and that became Blink One. And it's just a little, it's one of the simplest circuits. It's a USB connected LED that you can control via your computer. And so you just plug it into your computer, send it some commands, and it can be any color you want. It even stores color patterns. And so this became pretty popular because at the time you could hook it up to a lot of these internet services out there, like, Facebook, Twitter, whatever, and get little notifications.
Yeah.
Nowadays, that's much harder to do because there's been a lockdown of a lot of the APIs out in the world. So the sort of user level, like normal person level use of the Blink One has gotten sort of contracted.
Huh.
But the other main use of it is a lot of these people who own racks and racks of servers and need to know, what is server 74 doing? They can plug a Blink One into every server and then write a little script on the server that runs and checks the status. And so in addition to their normal real monitoring, they can also have these sort of ambient visual monitoring of what the whole server rack is doing. And they can also like turn the light on if they need remote hand support. Like, hey, person who's going to unplug the server, go to the purple blinking server.
Yeah.
and that's the one, it's like, so you don't unplug the wrong server.
Yeah, definitely.
So that's kind of ThingM right now. It's really just a one product company, and it's really a one person company. It's like I'm the only kind of person that does the design work. I've got a couple of assistants that help do the logistics of things, and I wouldn't be able to do things without them. But we don't have employees. We don't have an office. Just my garage.
Oh, that's cool. Yeah, it sounds like you've had a really interesting background of working with hardware and software and firmware, and kind of like combining that over the years, along with just kind of was looking at some of the information that you had put on the page for your podcast that you had done with Paul Cutler, the Bootloader. And so I was kind of reading from that and was kind of intrigued by it. But maybe we could talk about that a little bit. That I know it's unfortunately not happening right now, but what was the Bootloader?
So Paul Cutler, who has become this sort of like really strong voice in the CircuitPython community, he created the CircuitPython podcast, and like maybe a year ago, 2 years ago, in the middle of last year, he's like, hey, what if we had a weekly sort of news podcast where we just talk about 6 things that we find pretty cool, and they're in this sort of embedded computer space, like the CircuitPython Arduino, probably like 3D printers or something. Things that people would previously have termed maker.
Yeah.
In the maker area. And I was like, oh, wow, I feel really honored. Thank you. This sounds great. I'd love to talk about stuff because I'm always finding cool things. And and a weekly podcast would at least let me remember them. Because sometimes you forget these cool things you think about. You bookmark it, and then a week later, it's gone.
Yeah.
And so that's what it was. And it was a lot of fun. I had to up-level my AV setup because he initially wanted to do it both audio and video as a podcast and like upload the video on YouTube.
That's why it sounds so good right here now.
Oh, thanks. But towards the end of the year, I think he got like he's editing the CircuitPython podcast. He was editing the Bootloader podcast. Like this was all Paul, right? Like I basically just was the talent that would show up. I felt really bad. And then his like work was like at the beginning of 2023 was like, hey, we need you to do a bunch of work for us. And so he's like, all right, something's got to give. And it was like both of the podcasts for a while. And I think he's just now brought back the CircuitPython podcast.
Yeah. It seems like they're doing it like seasons now, kind of like he'll record a large group of them and then release them weekly after a certain bit, which I think is a good sustainable practice, especially for somebody where it's not like a regular gig, so
yeah, totally. And because that's not time sensitive,
right?
Because it's like, let's talk about an aspect of CircuitPython or a cool project in CircuitPython from the project creator. It's a little bit more, the content lasts longer. So if it comes out this week or it comes out next month, it's not as important.
It's got a bit of an evergreen kind of thing. It kind of surprises me.
That's the term I was looking for. Thank you.
Yeah. I'm amazed. I have listeners that tell me very often that, oh yeah, I just found your show and I've been listening through all of them. And I'm like, wow, okay. That's a lot of time. It's a huge investment. Thank you for investing that much time and checking it out. But I worry about that sometimes when the stories that you're kind of covering. And so one of the things that I try to do is not do so much pure news. We'll do like maybe a little segment about it, but mostly we try to cover like projects and, other things. And I try to really push people toward like, hey, what can you do with Python right now?
Totally.
Yeah. You were mostly working in C originally. That's where your background kind of started.
Mm-hmm.
How did you get into playing with Python?
Well, so I'm a big fan of the Adafruit people. Adafruit are the ones who are currently financially sponsoring most of CircuitPython development.
Yeah.
A good friend of mine, John Park, he does these weekly live shows for Adafruit, and he would occasionally, this is like, I don't know, three or 4 years ago, would occasionally ask me these questions because he's a pretty good programmer, but he doesn't come from programming.
Okay.
I don't know if that makes sense. Like I've been programming since I was like 12, and so a lot of these concepts just sort of have soaked in.
Yeah.
And a single word will trigger the association that this is what they're talking about. Whereas JP doesn't necessarily have that. So he's like, what does this mean? And I'd be like, I don't know what this means. This is in Python. I don't know Python.
Yeah.
Because like all the like real Python, the C Python that I'd done in the past were these contract jobs where I'd kind of come in like on a virtual zip line, do the work for 2 months, bang out some Python that would do some thing, and then zip out. And I'm sure my Python is terrible because it was written like either C code or like Java code.
Yeah.
It wasn't idiomatic in Python at all.
Right.
And so he would ask me these very, very simple questions about like how Python would do a thing, and I'd be like, geez, man, I don't know. And so I started looking into CircuitPython. I'm like, oh, this is actually really, really interesting because, how to say this succinctly, it solves so many of the initial chip configuration problems that I have encountered with doing an Arduino project of any complexity.
Okay.
And so to give an example, let's say you've got a little project that's got a display and it's got a couple of buttons and it's got an SD card and then like maybe a little audio output.
That sounds actually like a lot.
Yeah. Well, that's the thing is I mean, like in terms of like compared to a real consumer electronics product, it's super simple.
Yeah, it's much simpler.
But like, let's say like you're just making something that just plays a couple of sounds, and you want a little display that just lets you pick which sound to play. And so you got display, a little audio out, a couple buttons, SD cards, so you can load up the sounds. Doing all that in Arduino is a lot of work, and you can do it, and it's possible. But in CircuitPython, because the drivers exist for those functions, this is kind of one of the downsides is the driver has to exist.
Right.
But because the drivers exist and the drivers have really good error messages, when you try to use them incorrectly, it'll tell you in the REPL, hey, I can't do that. Instead of in Arduino, and it'll tell you, and it's line 13 that is the problem you're having. Whereas on Arduino, when you do the same thing, it'll just crash. And you're just staring at your board, your blank dead board, trying to figure out why it's not working.
Yeah. I see what you're saying. Like that's one of the things that I think is fascinating about it, and the almost sort of velocity that Adafruit and the CircuitPython team have with a new product comes out. Okay, great. Well, we should build libraries that support all the different things in it, so you're not having to cobble together your own collection of libraries to address all the separate circuits that this one thing does. They'll actually make a thing, and so now when you import board, it's for like that specific board, which supports all those different things. Which,
yep.
Yeah, it's like how much work have they done for you as somebody who's probably doing done embedded stuff for a long time.
Yeah, and so now my current sort of strategy for bringing up a new concept, like a new PCB idea that does a thing, even if it will be eventually written in Arduino or some lower level C, is I bring it up first in CircuitPython because I can check to make sure that everything can actually just work. Like it doesn't have to work well necessarily, but like for instance, in these modern chips, so let me back up a little bit. In old Arduino, the original chips that were used in Arduino, the chip on it had like maybe 20 pins that you could use for something, and some of those pins were explicitly for certain functions. So like pins 0 and 1 were for serial transmit and receive, and pins 6, 7, and 9 could be used for PWM, which means you could use them to control servos or use them to change LED brightness. And like maybe pins 17 and 18 could do analog input, and that was it. Like if you wired your circuit up differently and you're like, oh, how come I can't control my servo on pin 5? It's like you had to rewire your board.
Okay. It's only allowed to be input and not output, or
Exactly that, exactly that. And so the chips nowadays, it's like this next level up. They're based on ARM cores usually, but every pin, like almost every pin, can be reconfigured to be a bunch of different things. And some chips, like the ESP32 series, almost every pin can do every function.
wow.
which is nuts. But like but the more common case is you have sort of this crossbar switch idea inside the chip, and it can only make certain types of connections. So while you could have, say, PWM on every pin, you can only have, say, serial transmit and receive on pins 0 and 1, 7 and 8, 12 and 14, da da da, and there's also maybe a second serial port that can also be on some of those pins. And if you choose poorly, you can end up making that crossbar switch not do the thing you want. And it's really hard to tell that in Arduino. But the way that CircuitPython's drivers are written, when you try to instantiate these various high-level objects, like the serial object or the pin object, it'll tell you, oh, that thing's in use, or you can't do that on those pins.
Huh. Reminds me of like interrupts on PCs,
Totally.
15 years ago. It's like, oh no, you can't put your sound card on that one because this one's using this for this, board you bought already or something.
Yeah. It's very similar to that. Like electrically, it's very similar to that actually. And so having CircuitPython kind of help you do the design work of like, okay, I want to use a display and an audio output and buttons and a knob. Where can I put that? And you have on your breadboard like the chip you're going to use, and you wire it up and you try to do it in CircuitPython, and it says nah. And you're like, okay, why is it saying nah to me? And you're like, oh, I see. I can't have the serial on those 2 pins, but I could have them on these 2 pins. And you just change the wiring real quick, and you're like, okay, great, this works. And so then you can just change your little PCB that you're making, and when you send it off, and you get it back, and the PCB works first try.
It's interesting that you mentioned that you say you started on something like CircuitPython, kind of lay out what this project, prototype it at a certain point, and then you may switch it to Arduino. What would be the purpose of switching it there? Is it because of the fact that it's running C or doing something different, or?
Yeah, it's really, so one of the things about Arduino that is really powerful is that it presents this language that's sort of like C++, but is much friendlier. It's like very much C++ with training wheels. And a lot of the functions you call are actually C functions that just have really simple C++ wrappers. And so anything you do in Arduino is running at sort of the full speed that the chip can do. And for things written in compiled languages, and for functions where you need to be a little faster, you can then just write the function in assembly language and put it in your Arduino sketch, and that'll work. That makes it then bound to that particular type of chip, but you now get the benefit of like, oh, I know how to write things in assembly language. Like let's say hardly anybody does, but if you needed to do that, that is a thing you could do. So Arduino doesn't present you with very much of a floor. Like you can go down to the very bottom of the chip in Arduino if you need to.
Okay.
And so that's really great. So you can use the ease of Arduino where you can, and where you can't, you can drop down to the really low level stuff. But in CircuitPython, you can't do that. CircuitPython, it has this floor that is Python, and Python, and the CircuitPython sort of kernel, or what do we want to call it, the supervisor, it only lets you do things so often, like so fast. And so if you want to blink an LED really quickly, say, like just toggle a pin, you're at a for loop to do that, and it can only be so fast, like on the order of milliseconds. Like generally, if you want to blink an LED, you do something like a PWM module, which CircuitPython totally supports. But where this comes out for me is, say, if you're making a musical instrument,
yes,
and you want to make a sequencer, and you want it to have very accurate timing, because there's no accurate timing mechanism in CircuitPython. And even if there was, you're still at the mercy of the garbage collector, which will run every once in a while and suddenly throw all your timings off by 40 milliseconds. And so it's hard to do accurate timing basically in CircuitPython, which is why you want to switch to something like Arduino.
Okay.
And yeah, there's ways to sort of ameliorate it. You can purposely run the garbage collector yourself periodically. You can make sure you're doing things that preserve memory as much as possible and don't do a bunch of allocations to like minimize the amount of garbage collection that does get done. But you're still at the best, you're going to have this like plus or minus 2 or 3 millisecond sort of wiggle in your timing, which doesn't sound like a lot, but if you think about it, like a 16th note at 120 BPM is like 7 or 8 milliseconds.
Yeah.
So it's like it's already, your timing is going to sound kind of wonky if you're doing a sequencer of any kind of complexity.
Okay.
So yeah, that's basically why.
Yeah, no, it makes sense. Like it sounds like it's one of those things I always liked about MIDI generally, is that it's kind of a similar thing where you can, as a protocol, you can tell it to do, specific things. You're basically remotely controlling lots of things. And I kind of think of maybe as CircuitPython kind of the same way, that MIDI's too slow to do actual sound, to come out of it. That was always like a big problem I had with trying to teach the subject to my students. They just, it's like MIDI is not actually sound.
Yeah, it's a really hard concept to get across.
Yeah. And so, but it's just allowing you to control it. So I wonder sometimes about like, is there a way to bridge the two the way that like Python uses these sort of additional libraries like that are written in Rust or other things like that can be sort of hand off the code into these optimized compiled sections, but maybe not on this sort of level of embedded systems that you would switch from one language to another after you've prototyped it.
Well, that's the thing is that's what you do to do anything. To do everything interesting in CircuitPython, you are doing that because there's the core libraries that exist in the flash of the CircuitPython that's running on your chip. And that includes a bunch of functions for like the sort of medium to high level of chips that CircuitPython runs on. It includes like being able to access the file system that exists on the chip itself that looks like a flash drive to your computer.
Yeah, that's an amazing thing.
That includes things like being able to read WAV files for audio playback. That includes things like being able to access a frame buffer to do display stuff, both like on little LCD displays, but also now, thanks to a hack, on actual HDMI displays. And this is like on a little $4 board. Running CircuitPython, you can write to an HDMI display and like have it display things. It's amazing.
Yeah. I think I saw that project. I'm very interested in it. Like, I'm wondering about like sort of the visual synthesizer kind of thing that you could do with that. Would you need to, like, I think I was looking at a project that you were kind of showcasing somewhere in Mastodon as like a link or something like that. And I was like, oh, this looks cool. A friend of mine is like a visual synthesizer freak. He just loves that stuff.
Oh, cool.
He's a big fan of, Yak, the coder guy from, he's done a lot of video game stuff, but he's created lots of visualizers over time. But anyway, that idea of it, like able to fire the HDMI, at that point, you're saying it's using sort of a already written library to access aspects of it, but still using CircuitPython.
Yeah. So one of the things, Scott Shawcroft, the CircuitPython lead, who you had on your show like, I don't know, 3 years ago or something, which is a good episode. Everyone should go check that one out as well. CircuitPython. But he very early on made this core library called Display.io.
Okay.
That is a pretty high level API to drawing onto displays. And so instead of just like having pixels, like XY and the color of the pixel at XY, you instead have sort of like sprite sheets.
Okay.
Where you say, at this XY position and this width and height, I want you to draw this bitmap. And you just give it the bitmap and it takes care of drawing it for you. And then later you say, now I want that bitmap at this other XY location, and it just redraws it for you. And so within like a few lines of code, you can make a little game.
Yeah.
Because you're not doing this low level, how do I draw a circle? How do I draw a line? You're just like, oh, this bitmap that I uploaded on the CircuitPy drive, draw it over there. And now draw the enemy bitmap over there,
Huh. Yeah. Wow.
And so it's really easy. And so the way the HDMI stuff works is it just uses Display.io, but it has a different output device. And so you just kind of set that all up, and then all your previous Display.io stuff that you may have done before on little tiny displays that you hold in your hand can now go onto monitors that you would normally hook up to your computer.
That's cool. Yeah,
it's amazing.
I'll definitely try to include links to some of that stuff and some of those. I tried to order that. There was a board recently. It was like a Pico with a
Yes.
DVI.
The Adafruit Pico DVI Feather, I think is what it's called.
Yeah. It was out of stock, and I think it's popular, so it kind of comes in and out of stock. But
yeah,
so I haven't grabbed one yet. But in kind of a similar vein, we were talking about creating audio, and a handful of projects that you've kind of been focused on lately have at least things you've been linking to. Well, one was you were very interested in Mozzie, which is a Arduino library for like doing synth stuff.
Yes,
if I'm pronouncing it right.
Yeah, I think so.
And then I don't know if Synth.io is quite to the level of what Mozzie's doing, but that seems to be a new library for CircuitPython.
Yeah, so one of the other really cool things is CircuitPython has really good audio output support. So there's three different technical ways you can output audio from CircuitPython. So you got a lot of different choices. It kind of depends on which chip, because like different chips support different capabilities. But anyway, once you have the ability to output audio, well, it's like, what can you output? Well, one of the other things that CircuitPython makes trivial is if you want to play a WAV file, you can just really easy in like 3 lines of code, pipe a WAV file that's on the files on your CircuitPy drive out the audio device. And so for making things like little sample players, which was one of the first things I did, you can just whip that out really quick because here I've got a directory of WAV files. Here I've got like 12 buttons. And every time you press a button, it plays that WAV file, and that's so easy. So if anybody's interested in sound, I quickly steer them towards CircuitPython because I'm like, you can get a lot of bang in a small amount of bucks with just doing with just doing WAV files. But the problem is that for the longest time is that was all you could do is you could just play WAV files. And if you wanted to do anything else, like the Mozzie library you mentioned it's a full synthesis. It was actually made for the old 8-bit Arduinos. So everything about it is 8-bit. Like the samples the oscillators are 8-bit, the filters are 8-bit, and
sounds very sound chip from a video game system kind of.
Yeah,
stuff.
yeah. It's just got this kind of fun lo-fi sound. Like there's some parts of it that have, I think, over time, because I've been using it for several years, but over time it's gotten a bit more hi-fi if you want it to be.
Okay.
But the fact you can run it on these ancient Arduinos and run it on the very modern Arduino capable chips is like pretty amazing. And so I've been playing with that, making cool little fun synthesizers with that. But it's an Arduino and it's kind of grungy, but it is very much like a modular synthesizer in code where you've got like, here's an oscillator, here's a filter, here's an LFO, here's an ADSR, and you plug them together however you want to make whatever crazy sounds you want. And that's really powerful. If you don't want to go and spend all the money on modular, you can kind of write code to do modular in Arduino. And CircuitPython didn't have any of this. You could play WAV files, but you could really only play WAV files at just even one speed. You couldn't even change the pitch of the WAV files to like kind of get a fake piano sound by playing the sound at different rates.
Much more like a drum machine playback
exactly.
versus like a true sampler being able to change the octaves and whatever.
Yeah. So I made tons of little drum machines in CircuitPython because it was so fun. It's like just plop down this directory of samples, and then suddenly you've got another whole new different drum machine. But in the last, I think maybe 2 months, one of the CircuitPython devs, this guy named Jeff Epler is his whole name, but his handle is Jepler. Somehow he got the time to work on what is now called Synth.io, which is a synthesis library for CircuitPython, and it's built in, and it's really cool. It doesn't follow the standard sort of techniques and names that like Mozzie does of all the various things, but it can do a bunch of different things that you can't do in almost any other synthesis library. Like it is a sort of waveform, these little single cycle waveform oscillators are sort of its basis, and it's set up such that you can modify those waveforms in real time as the oscillators are playing, which means you can do a type of wavetable synthesis or granular synthesis or like all this other stuff that was like really hard to do for a lot of synthesizers for the longest time. And so you can make some really crazy sounds with a pretty small amount of work. And it's, of course, fully repitchable, and it's got amplitude envelopes and LFOs and these math blocks. It's sort of like a modular-inspired logic system for like combining LFOs and envelopes and stuff. And there's a PR right now for doing some initial filters, which is pretty cool. Like one of the cool things about wavetable synthesis is you can fake filter sweeps by modifying the waveform oscillator in various ways.
Yeah, just change the shape of sorts, right?
Exactly that. Yeah. And so as Jepler was working on this, and we were talking about filters, and he's like, well, how important is filters? And I'm like, well, we can kind of fake it by using the wavetable stuff. And he's like, well, let me give it a go. And so now there's a PR for like, a high pass, low pass filter, band pass filter, notch filter, I think. And so it's just like, wow, it's like, I'm so glad to see this effort, because it seems like such an extra thing that wouldn't be in the core, but it is in the core.
Yeah. So, I thought that was kind of wild. Yeah.
So yeah, but this gets to one of the problems currently with CircuitPython to me, and I don't know if there's a solution to it. You mentioned the way that in normal Python you can extend it with these native modules, like the most common is NumPy. Like if you want to do operations on big lists of numbers, you don't do it with a for loop in Python. You don't do it with a list comprehension. You load up NumPy and you use the NumPy operations to do like math on those lists.
Yeah.
And right now, CircuitPython doesn't have the ability to load native code that's not built into the firmware of CircuitPython. And so right now there is sort of a tiny version of NumPy that's built into CircuitPython, but it only has a small subset of the functions available. And there's no way to add more, because if you added more there, it would kick out some of the new cool stuff. Like it would kick out SynthIO eventually, right?
Yeah.
So it would be really cool if like someone could make the really big, fully featured NumPy that you could then load in and have it do all the fancy stuff that the bigger NumPy can do. But we can't do that yet. But there's potentially a way of doing it in MicroPython, and I think this got ported to CircuitPython. There is a way potentially to load native code, but I've not looked into it much yet, because even writing just writing C modules for CircuitPython is a pretty heady task. Like I've done a little bit of it. I can get stuff done, but I can't get stuff done to the level of quality to be included into the core.
Right.
And so I would love to be able to play in my own space with my crappy code that doesn't impact anybody else.
Sure.
And that have it be something that someone else could download without having to recompile their own version of CircuitPython.
Yeah.
Which is right now, that's kind of the solution.
This week, I want to shine a spotlight on another Real Python video course. It covers a topic critical for your Python programs to work with text, data, or any type of file. The course is titled Python Basics, Reading and Writing Files. It's based on another section of Real Python's book, Python Basics, A Practical Introduction to Python 3. The video course is presented by Real Python author Bartosz Jaczynski, and he shows you how to understand the difference between text and binary files. You'll learn about character encodings and line endings. You'll get to work with file objects in Python and read and write character data in various file modes. You'll also learn how to take advantage of the CSV module to manipulate CSV data. Working with files will be crucial as you continue your journey as a Python developer, and this course is a worthy investment of your time. And like all the video courses on Real Python, the course is broken into easily consumable sections. Plus, you'll get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So you had mentioned this is a link that you had on the bootloader, was this thing called MicroLab, or, it's the micro letter, the U lab. Is that what you were talking about?
Yeah.
Modeled after NumPy.
Yeah. So for some reason I don't understand why, but it's in CircuitPython the package is called ulab.numpy.
Okay.
And I think ulab stands for microlab, like maybe, I don't know the reason why it's called that. I think perhaps there was an envisioning that other scientific functions would go under the ulab space.
Yeah, okay.
But
all right. And you could choose to add that or not have it or something like that.
Yeah. But I mean, I think there's only one entry in the ulab namespace, and that's NumPy. And so everybody just imports ulab.numpy as NP and then does the standard np.array sort of things.
Yeah, so they can do some vector kinds of stuff, but it doesn't have all the, it's not the full library. It's just...
Yeah. What is there is super handy. Like one of the things I used it for that I wrote a blog post about a year or two ago, which is, let's say you've got a set of NeoPixels, LEDs, addressable LEDs, and you want to do the cool effect where you light up LEDs sort of randomly and then you fade the entire strip down to black.
Yeah.
And so the way that works is you would basically, you pick a location randomly from like 0 to number of LEDs, and then you set that random number, that random location to the color that you've picked. And then for the entire strip, say with a for loop, you go through each LED and you reduce its brightness by some amount. And so for every loop, you're reducing the brightness a little bit. And so that's a fade to black. And so you could do this with a for loop, and that's what most people do, and it's slow. But if you just recast that data as a NumPy array, and oh yeah, so okay, you're a Python person. Is it NumPy or NumPy?
It's NumPy, yeah.
Okay.
Yeah.
I called it NumPy for years. People looked at me and I was like...
It's how many people call the Pi Pi, they call it Pi Pi, and it's like, well, actually, that's a separate thing. It's like,
oh, wait, it's not called Pi Pi?
No, yeah, it's Pi Pi, because there's a package called PyPy that's called Pi Pi.
Oh my goodness! All right.
Yeah.
This is a problem that all my Python stuff is just done by myself, but in my head, I don't really talk to anybody about it. That's hilarious.
Like, you start speaking stuff out loud, you're like, what? I can write pretty well, but speaking, it's hard.
So is it tuple or tuple?
Yeah, that's up to you. I've had that battle already. I did a course on it. Yeah.
So the problem with dimming these LEDs with a for loop is that it's slow. So you do it with a list comprehension. It's a little faster, but it's still pretty slow. But then if you cast the pixel data into a NumPy array, and then do the just NumPy.add, like a array.add on that with a negative number, that will do that really fast, like 10 times faster than any pure Python solution. And that's because you're doing it in C. Like you're calling the C iterator function inside of NumPy that is doing the iteration across your array. And so that makes NeoPixel animations look so much better. It's amazing how much better it looks just from this like simple. I'm just going to think of all the data as NumPy arrays, and then at the last minute convert them to the list of tuples that the that the NeoPixel library wants.
Yeah. I could imagine you would like see the gradation of it, like there it went down a little more and there it went down more, and now it's like smooth,
Yeah, no, exactly. You see the stair stepping, and if you want a nice slow kind of fade out, it's like dunk 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 dunk, and it's like, oh, you put it as NumPy, and it's like boom, but it just looks smooth. Yeah. It's awesome.
Yeah, cool. Yeah, I could see how that could combine to, again, the audio stuff or the other video stuff that you're mentioning. Yeah.
Yeah, exactly. Like all the waveforms in SynthIO can be NumPy waveforms.
Yeah, okay.
And sorry, can be NumPy arrays. And so you can do a bunch of NumPy math. Like one of the ways I was doing the fake filter is we do have the NumPy FFTs. And so one of the ways you can do a quickie filter is you do the FFT of the waveform, and then you chop off the higher coefficients, just set them to 0, and then do the inverse FFT to convert it back into a waveform. And so that's one way of going from waveform to the frequency components of the wave, chop off the high frequency components, and then make it a waveform again. And boom, you've just now low pass filtered your signal.
Yeah.
You can't do that in real time, of course. But, if you need to convert a square wave to something less of a square wave, you can use that.
Yeah. So there's so much I want to talk to you about. One of the things I was thinking about was just, kind of for that more... these types of projects, these more sort of advanced things that you get into, I could imagine that somebody might say, well, what types of tools or boards or other kinds of things would be good places to, not start, but to go maybe next.
Yeah, yeah.
And so maybe we could start with that, like the board kind of thing. You do a lot of projects with the Raspberry Pi Pico, where you've created 2 or 3 different things. Maybe we can mention just briefly here, like your Pico Touch, sort of touch keyboard, which I show everybody.
Oh, right on!
I love
Thank
that
you.
thing. Yeah, it's super,
awesome.
super
Me
cool.
too. I keep one in my laptop bag all the time.
Yeah, it's really neat because I bought one of those Korg touch things back in the day when they came along, and I'm like, oh my god, I can build one of these for this much, and all I got to do is just hopefully properly solder a Raspberry Pi Pico on it, and then to order the Raspberry Pi Pico from something like DigiKey and get them in like this plastic container that has like, it looks like chiclet gum or something like that.
Yeah.
You get like 3 or 4 of them. It's crazy. Yeah, I mean, I think of that board as like kind of a neat board. It is a Raspberry Pi, just with certain aspects of it.
Well, it's a Raspberry Pi Pico. So one of the very frustrating things about Raspberry Pi is so they made this very successful line of single board computers called Raspberry Pis.
Right.
Like the company is called Raspberry Pi, the product is called Raspberry Pi, and these things are computers that run an OS, they run Linux, they run full Python, they run Apache,
plug in a monitor,
anything you want.
Right.
Plug in a monitor, plug in a keyboard, plug in a mouse, and it's a real computer. You can run, Chrome on it or whatever. But then they came out with this amazing chip called the RP2040, and the first little board that carried that chip was called the Pico, but the full name of it was the Raspberry Pi Pico because it comes from the Raspberry Pi company.
Oh, okay. So confusion.
And so the problem there is that people hear Raspberry Pi Pico and they think, oh, it's like a small version of a Raspberry Pi. And it's like, no. It has nothing.
This is a different board. Yeah,
it's totally different, and so it's so frustrating because it's a pretty good board. I mean, one of the things that makes it really good is it's $4.
Right, yeah.
And that's one of the main reasons why I use them is that they are the easy to use, almost disposable board. Like I feel like because they're $4, I can do some experiments with it that I maybe wouldn't feel comfortable doing on a more expensive board that I care about.
Right. If I damage this, I'm not going to feel too awful.
Yeah, exactly. And because CircuitPython and Arduino work on so many of these boards, and often like a better board, like for instance, take that Feather DVI, that also has an RP2040 chip in it, but that's a more expensive board. It has a lot of extra features, like it's got a battery management system and it's got that big HDMI connector.
Yeah.
And so if I slipped with the wires and fried that board, I'd be sad. Because it like not only is it more expensive, but it's a bit harder to come by.
Yeah, it's hard to get right now. Yeah.
Right, and so like I can do most all the experiments I need to do on the Pico, and then once I'm like, okay, I think I know what's going on here, I can just copy my code over to the to the Feather DVI board, and like have maybe a couple of changes at the top to say which pins to use because maybe I chose different pins or something. I love the Raspberry Pi Pico for that because it kind of makes me feel less anxious about am I going to mess something up.
Yeah, you've done 2 or 3 projects. The other project I dig is the Pico Step. Is that what it's called? Pico Step Seek?
Oh, the
sequencer?
Pico Step Seek. Yeah. So I did that one last year, right before, it was 2 weeks before CircuitPython Day, which is a sort of annual thing that Adafruit has decided to create, of just like, hey, let's get everybody who likes CircuitPython to talk about it. At the same time, John Park had found a source for these things that he called step switches, which are these cool 80s looking switches that have a built-in LED. They're kind of big and chunky, and they
look straight off an 808 drum machine.
They're so just lovely because they go click click click, and they've got this red LED that just looks very 70s 80s, and so I'm like, oh man, a Raspberry Pi Pico, 8 of these switches, a knob, a little display, and MIDI out. Okay, I can do this in 2 weeks.
Wow.
Yeah, so whipped up a quick board because every pin on the Raspberry Pi Pico can like do a bunch of stuff. It was really easy to wire up. Like I didn't have to think too hard about how to wire it up. And I just sent the board out, and while the board was working, I worked on the software on the Adafruit Macro Pad, which is basically the same sort of setup. It's got 12 buttons, it's got a better display, but I was able to get most of the sequencer working. And then when the board showed up, I just quickly soldered it together, and and it worked. And and it was a pretty usable little MIDI step sequencer in a size about the dimensions of a paperback book. And yeah, the total cost was like, I don't know, maybe $30 in parts or something.
Yeah, it's a fun project. Yeah, it was my first time really playing around with CircuitPython with a display, and that was kind of interesting. That it was like, oh, okay, just connecting it into this board, and it just worked, which was really nice.
Yeah.
My hardest part was the 3D printing and making sure I had the height of the Pico correct, because I ended up soldering it right down at the board level instead of using the standoffs.
Right. Yeah, I struggled so hard with that. So, like the little 3D printed case I made is like totally a hack job that I did in one day, basically. And so it's got a lot of problems, and I'm good on you for actually getting it to work a little bit.
It's here. It looks really pretty. It's printed in yellow and blue.
Oh,
and you
that's
can hear
awesome.
all the little switches.
Very good.
So, yeah. It uses the 1/8 inch jack version of MIDI, which is really kind of cool that you can use those plugs. And so I think you have the same little synth, the Korg digital.
Oh, the NTS1, yeah.
Yeah. I love that thing. It sounds very, very cool. So just playing around with that.
Totally.
Tie it together. Yeah. So if you were going to start a project today, that would be a pretty common board for you to reach for, would be the Raspberry Pi Pico.
Yeah, I would say because it does require you to solder a little bit. I would say the big fork in the road is how comfortable are you with soldering.
Okay.
And if you're a little bit comfortable, then I'd say the Pico's fine. But one of the cool things that both SparkFun and Adafruit have done is they've made a line of boards and sensors that don't require soldering. They it's the same protocol, but SparkFun calls it Quick, QUIIC,
Okay.
and Adafruit calls it Stemma QT, and it's essentially I2C, which is a smart serial protocol. Uses 4 wires, and so these boards will have these little jacks. And so if you want to hook up a knob and a slider and a display and a little like temperature sensor, you can just get one of the Adafruit boards that has a Stemma QT jack on it, and get some of these boards like the knob or the slider, the temperature sensor that has a Stemma QT jack on it, and just plug them together with cables. And so there's no soldering. And so then later, if you want to like then move up to a board where you've designed it yourself, or maybe build it on a breadboard using the same parts but cheaper, you can then start to explore soldering up your own stuff.
Yeah.
And that's really easy to do. But like it's really fast to get going with the Stemma QT stuff. If you just want to try out an idea like, oh, hey, yeah, would a lit up key switch be cool for this idea? Let me try, click a click.
Yeah, totally. I think the in between the two would be maybe putting the standoff leg so that you could insert it into like a breadboard or something like that.
Yeah, that's typically my methodology. Is I will solder the breadboard pins, the header pins, onto the Pico. Then I plug the Pico into a little solderless breadboard, and then I get like random little devices that also have the breadboardable header pins and stick those into the breadboard, and then I'll run jumper wires between the Pico and the board, whatever the board is. Like lately, it's been a little audio output boards and pots and knobs and stuff, so I can make little synthesizer toys.
Yeah.
But that's a very quick way to try stuff out. It's not very stable because all this stuff is kind of like held together with spring-loaded bits of metal, and so like if you shake it too much, it'll come undone, but it's good for trying stuff out.
Yeah. Okay. One of the things that I was impressed with some of the projects that you've built when I was watching and actually kind of learned it more from your videos is, most of these boards need power. So like you're going to need, if it has audio outputs or something like that, you can definitely connect there. But usually the power is brought in by the USB connection. And so you're using these, they're almost ubiquitous. Like they were like the thing that you got at a conference or something like that was like the little battery, like charge top off your phone battery. And I ended up never using it for that because like the phone batteries were fine. And I ended up like with like 10 or 12 of these things laying around. And I got a fantastic one from last year's PyCon. AWS had this huge one that it's like kind of coated in rubber and has like suction cups on it and has 2 outputs. And so I actually can power my projects then, I can actually, instead of having to because That's one area that I've kind of failed at. I've been trying to get better at. Is like, okay, well, I want to make a board that I can maybe do Bluetooth with, and so now it needs to be remote and have power.
Yeah.
And I'm like, oh, how can I do this easily? And I think that might be the easiest way to kind of get around it, because the batteries are pretty massive in these things,
Yeah, yeah, but and that's kind of the strange paradox of these little phone charger bricks that like were so common like 10 years ago or so, is that nowadays our phones' batteries are so big that these little like lipstick ones that we used to get at the conferences, they will maybe add like 2% or 5% of charge to your phone.
Yeah, it's like
yeah,
topped it
they're
off.
useless. Yeah, they're useless for that. But because like these little microcontroller projects, they draw like 20, 30 milliamps, which is like 1/10 of what, or sorry, 1/100th of what a phone will pull. So you can run these little projects off of these normally junked USB power banks for hours.
Yeah.
It was kind of funny that this most recent, I made a little video earlier today, and I'd forgotten this little like lipstick kind of shaped one that I'd been using for like months, where I'd use it for like maybe half an hour, then I put it away, use it half an hour, put it away. It finally died on me today. I was like, oh no, I was in the middle of recording this video and it died.
Yeah. It's like, surprise. You do have to charge it occasionally, maybe before you record. Yeah. Too funny. Yeah, I was impressed with that as a technique. I'm like, oh, actually, I can power the little synthesizer and the sequencer at the same time. And yeah, it's kind of nice. Kind of a neat trick. Some of the other things that I've heard you talk about, not only on the bootloader, but just kind of seen you mention otherwise, were kind of tools for the person who's getting a little further into CircuitPython. And I think that you mentioned that you're not a big fan of IDE kind of stuff.
Yeah.
What are resources you would use, like if you need to make sure that your projects, maybe you're trying to test out a sensor and see, like, is it receiving the right numbers and so forth, as far as coming in and out of the board? What are some of the resources you use there?
So I like to divide these up into sort of two areas, software and hardware.
Sure.
For the software tools, the way I program is I'm an old school programmer, and so I program by having a text editor window and one or more terminal windows open.
Okay.
And that's how I've been programming for decades. And so that's how I program in CircuitPython, is I have a terminal window open that I use a tool called TIO. But you can use any serial terminal program to connect to the virtual serial port that CircuitPython presents to you. And that's where you see the CircuitPython REPL. And then in the other window, I have the code.py open. Sorry, in the text editor window, I have the code.py open that is on the CircuitPy drive of the CircuitPython device.
Okay.
And so my sort of standard workflow is I make edits to the code.py, I save it, that causes a reload that I can see happen in the terminal REPL, and I can see how my code is working. And so that works great. It also is very transferable. You can do that on a Chromebook. You can do that on an iPad. I've even done it a little bit on an iPhone.
You're opening terminal windows that way?
Yeah. There's a little terminal program that I've got for the iPhone that I found somewhere.
Oh, awesome. Yeah, cool.
Even if you don't have that, you can still edit the code.py and watch it run. And so it's just compared to how you had to install the Arduino IDE and that only ran on certain computers and stuff, it's really kind of cool that, like, wow, our microcontrollers are becoming so powerful that they can become sort of citizens of your computing space rather than these pure peripherals. So that's kind of how I work, is terminal and code editor, text editor. Then you're like, well, what is the equivalent of pip in the CircuitPython world?
Oh, yeah.
And for a long time, there hasn't been one, but for like years now, there's been this thing called circup, CIRCUP, written by this guy named Nira. His handle is Niradoc. This is open source. You can get it on GitHub. It works on all the platforms, and you can use it very much like pip, where you just say, hey, I want to install this library, and you just say circup install library name, and it gets put onto your device for you. And that is super handy because a lot of the really hard work is done by these libraries. And so having that is super handy.
Yeah, I was impressed with that. Like that was the one that I was like, oh, I didn't know that was available. And when you had, I assembled everything and kind of put it together. And, normally you would have to go find the sort of collection of additional libraries and then, physically move them into the appropriate directory in the, flash drive like area of the CircuitPython device that you're going to. And this is just does that automatically. It knows the destination. And I thought that was really a handy little tool.
Yeah, it's super powerful because one of these sort of official ways you install these libraries is you go and you download the zip bundle and then you unzip it and you pull out the library and you hand drag and drop it over to the CircuitPy drive. But in all those steps, there's a lot of ways you can do it wrong.
Right. Or you're duplicating stuff sometimes too.
Exactly. And one of the worst, because CircuitPython has a couple different paths that it searches for libraries for, like it's got the current directory that your code.py is in, and the lib directory, and, and maybe you've got something else. But it's very easy to have multiple versions of the same library, and it's really hard to diagnose those sort of problems. You're like, but I just deleted the library. How is it still loading the library?
Right. Yeah, totally.
So circup can make all those problems go away. Another tool written by the same fellow is called discotool that lets you find the drive name and serial port name of the CircuitPython device plugged into your system, which is really handy, I found, on Linux and Windows, where I always forget where in the dev tree on Linux that the serial devices live, and I can never find COM ports on Windows. I don't. I always have to dig through Device Manager and stuff, and I'm sure there's a faster way of doing it, but just running discotool solves the problem.
Okay. Would that help with the TO at all? Also, learning port numbers and things like that?
Exactly. Yeah. It'll tell you which port to use with TO.
Cool.
Yeah. So it's like discotool to find where your device is in your computer. Use circup to install libraries onto the device, and then TO to connect to the serial REPL of the device.
Nice.
And then whatever text editor you like to use.
Yeah. One of the things that I want to mention is I don't know if you're already going to mention this, but you have a nice repository on your GitHub of CircuitPython-tricks.
Yes.
Which I think is mainly, you write it as I always forget these things and need to remember them. And I'm that way too, certain, techniques and stuff that I do. It's it's nice to have it's almost like a little awesome list of stuff to,
thanks. Yeah.
to remember how to do.
Yeah. So one of the things I have is in my home directory, I have all these name of thing -hints.txt. And so I've got git-hints.txt and, python-hints.txt. And I've got all these little text files that I've been editing. Some of them I've been editing for 10, 20 years, especially the GitHub one, or the Git one. That one's just full of random things that I've had to, because who can remember all the crazy command line switches to Git?
Right.
But yeah, so I started creating a similar one for CircuitPython. But then John Park kept asking me, he's like, wait, now how do you do this thing? And I'd be like, oh, and I'd just quickly copy and paste it to him. And he'd be like, man, how is it you're so fast with that? He's like, you must know Python really well. I'm like, no, I just did a search on this CircuitPython hints.txt file and just copy and pasted it.
Nice.
So he kind of convinced me that I should post it online somewhere. And so much of the content of CircuitPython tricks is inspired from John Park's questions. And
thanks, John.
Yeah, totally. Yeah, it's at github.com/todbot/CircuitPython tricks. You can find it in the show notes, I assume. Yeah.
Yeah. I'll definitely include the links for that. I got a pretty healthy list of things I'm going to be linking to. So.
Oh, excellent. Thank you.
How did you get the name todbot? Is that something you created on your own?
No, it was a name given to me by my best friend in high school long ago, and I did not like it for the longest time. I told her I was never going to go by it at all, and then in the 90s when when people were buying domain names for things to make your own domain name,
right?
I decided, I might as well use this as my domain name, and then that kind of became my handle.
Yeah, I have a handle of off and on. I've used it called a sound orphan.
Oh, that's awesome.
This friend gave it to me. She's like, you have all these songs that have no homes.
Oh,
Basically,
no.
all these are like random like pieces of music, and it's like, yeah, these are my sound orphans.
That's awesome.
So, yeah.
Oh, one last software
Yeah,
tool
go ahead.
is this online simulator for the Raspberry Pi Pico and other chips.
Okay.
It's called Wokwi, Wokwi, and you can use it to run CircuitPython on a virtual Raspberry Pi Pico in your browser.
Nice.
And you can hook up little virtual LEDs and virtual buttons and other stuff. And so if you're interested in playing around with CircuitPython and trying to see like how it differs from normal Python, you can like right now go to this website and play with a virtualized version of a Raspberry Pi Pico running CircuitPython. And it's pretty good. I actually try out a bunch of things when I'm like trying to figure out, okay, what's like the more sort of Python way of doing this idea. You know, I kind of taught myself list comprehensions while using this, you know, because I wanted to make sure, because I wanted to make sure that like, oh, do the things you can do in normal Python also work in CircuitPython for this list comprehension stuff? And it turns out the answer is yes, like because it's pretty much Python. But at the time I was like, I don't know, you know.
Yeah, that's cool. Yeah, that looks really nice. I've seen a few other kind of resources that kind of are similar, but this seems much more complete and has so many different of the boards, and then also you being able to try it out with lots of the different languages to kind of mess with them, which is cool.
Yeah. It's a little much now, because there's a lot of things that Wokwi can do. So I'll give you a link to the one that's just for CircuitPython to put in the notes.
Nice. All right, great. Yeah, and I mentioned it briefly. You know, the projects that you have gotten into, like you said, creating the circuit boards. You know, going beyond the breadboard and trying it out in person. But that seems like a really kind of neat thing. And what sort of tools are you using to create the circuit boards that you do, or at least design them?
Yeah, unfortunately, I'm still using Eagle, which was the tool that everyone used in the sort of open source maker community, open hardware community for like a long time.
Okay.
But it got purchased by Autodesk, which initially was like, yay, because Autodesk put a lot of money into it. But then they started saying, oh, we're actually going to be moving all the Eagle schematic and PCB design stuff into Fusion 360. And it's going to be part of Fusion 360, and you're going to have to pay for it, and
Uh-huh.
And so, you know, I've got this permanently purchased version of Eagle that hasn't been updated in multiple years, and so at some point it's just going to stop working, and I'm just dreading that day. I've been slowly learning KiCad or KiCad,
Yeah.
and it's in so many ways so much better than Eagle. Like just from me goofing around with it, I'm like, wow. You know, where I've been like living in like the dirty part of town, and now I'm in like, you know, this awesome, cool, fancy town.
Yeah. I'm intrigued by Thea Flower's work on her. That will be kind of in the browser.
Yes.
I know it's kind of, I'm not sure if it's a 1.0 yet or not, but she's been working really hard on it. So.
Yeah, it's a KiCad viewer. So if you come across a KiCad schematic or board layout on the web somewhere, you can just drop the URL to it into her viewer, and you can just see it and scroll around and see all the parts and stuff and how they're wired up. And that's been super instructive to me. So big thumbs up to that. Thank you, Thea.
Yeah, definitely. Cool. Yeah, and so if people are interested, definitely will include links not only to the specific repositories we talked about, but also your GitHub generally, which has, you know, a ton of different projects that you do, and then some of the physical hardware ones. If people are into building projects, you still have some of the stuff up on Tindie, right?
Oh yeah. The people had always been asking me like, hey, why don't you put this random Git thing that you made and put a video up on? Why don't you make that available for us to buy somewhere? And I'm like, I'm not really into that, you know.
Right.
It's not really ready for prime time to be sold. I'm not really ready for the support issues of this. And for some reason, I don't know, last year I decided, okay, maybe I'll just like start putting some of this stuff up on the Tindie just to give people an answer when they have the question of like, hey, can I have one of these? Because when you get PCBs made,
yeah,
the sort of minimum order is 5. And so, it's like, well, I just need kind of 2. I need one to mess up on, because I'm going to end up messing up on it somehow.
Sure.
And then I need one to make it nice and look pretty, and then that'll be the one that I actually want to use. And so then you got 3 left over. It's like, okay, well, maybe if I instead buy 10 or 20, I'll still have the 2 that I want to use. Then I can just quickly put the other 18 in a bag and take a picture of them, put them on Tindie. And so that's what I've been doing. And it's been nice. It's been paying for some of my goofy experiments in synthesizers lately.
Yeah, the next project that you do.
Exactly.
Yeah, that's cool. Yeah, I always talk about this, that I'm just almost baffled by the idea that you can make 5 only, because I'm come from the era of the 90s of sorry, 1,000 minimum order of CDs.
Yep.
And it's
Yeah.
So yeah, it was very painful.
No, and it's so crazy how it's just so easy now. If you can whip up a board in KiCad pretty quick, and then just do what's called exporting the Gerbers, which is basically creating these standardized image files that you give to the board house.
Yeah, the layers of the board.
Yeah,
right?
Exactly. It's exactly like Photoshop. Like Photoshop layers or Illustrator layers, and then you just upload a zip file of those Gerber files to the board house, and they say, okay, that'll be $5 and then $20 shipping or something.
Right. Right. So funny.
Or if you want to do it in the US, like Osh Park is really good. It'll be more. It'll take more time, but it's a lot of times you don't care if it takes 2 weeks versus 1 week, and so.
Yeah. So cool. Awesome. Do you think we hit most of the stuff that you wanted to talk about?
Oh, one thing, and that's the hardware tools area. Real quick, we mentioned the USB power bank, which is great.
Yeah.
Other thing that I found really handy is a USB power meter.
Oh, okay.
Which is a thing that's got a USB plug on one side and a USB jack on the other side, and you plug it in between your CircuitPython device and your computer, and it'll tell you how
the draw,
exactly to see the power draw, and that's really handy if you inadvertently hook up something wrong. Sometimes if you hook up something really wrong, like short power and ground, your computer will just turn off that USB port. It'll go, hey, the USB board is pulling too much power. I'm going to shut it down. This is kind of one of the features of USB.
Right.
And but if it's a softer error, you kind of wired it up a little weird, and it's drawing 4 times more power, that's still within the USB power budget, but it could be damaging your board perhaps. And so by having a little USB power meter, you can go, hey, wait a minute, it was drawing 20 milliamps, now it's drawing 80 milliamps, I should unplug it.
Yeah, I've done something weird. Yeah, okay.
And so
that's cool.
Yeah, so that's really handy. It saved my bacon a couple times. The other is a little USB hub that has switches on it, so you can just for power switches. They're $8 or $12, and it's just a real quick way of turning on and off your board without having to physically plug and unplug it. That's all.
I don't like those jacks. I'm not a fan of. Is it micro, or which one is this one that's on almost all the boards? I can't wait for everything to be C, but it's probably too expensive right now.
Yeah. The Raspberry Pi Pico used a micro B connector, which is kind of insane, but
it's easy to wreck it. if you're being a little too hardy with it.
Yep. So the fewer times you're stressing that connector, the better you'll be.
Yeah, definitely. Oh, cool. Yeah, that sounds good. So I have these weekly questions I like to ask everybody, and the first one is, what's something that you're excited about that's happening in the world of Python?
Oh, see, this is where my lack of greater, the larger Python world is at a disadvantage for me. I think for me, I just want to learn more about sort of the internals of CircuitPython. One of the really nice things about CircuitPython, if you start looking at the GitHub repository for it, is you kind of get to see how Python thinks about things from the inside.
Okay.
And that's I find that really interesting. You just oh, it's everything's an object,
Yeah, totally.
And seeing how it thinks about numbers, which is very important when you're doing certain kinds of like data processing, like samples or waveforms or display objects or whatever. That's pretty much the main thing. Is I want to look into how the internals of the CircuitPython NumPy stuff works.
Yeah.
And see how some of the SynthIO stuff works. I've been very much keep myself at an arm's length with it, because I've been wanting to look in there and maybe trying to modify stuff, but I don't want to step on Jepler's toes because he actually knows what's going on and I don't.
Yeah. And this is probably related to that then. What's something that you want to learn next? It doesn't have to be programming in this case.
Let's see. I think I kind of want to look back. So my original schooling was in electrical engineering, and I actually had a bunch of DSP, digital signal processing, as my emphasis, and I've forgotten almost all of it. So I want to kind of go back and like relearn some of that stuff, and from a first principle sort of way, just to see like,
okay,
what is this biquad filter actually doing? You know,
wow.
Because I used to know it, and I don't know it anymore.
Yeah, I this is years ago. I think I found a resource that was like a Python, basically signal processing with Python, kind of like combination thing. I don't know if that would fall in the line of would be useful.
Interesting,
would hit the things you want, but it was definitely sort of learning about signal processing by playing around with it with Python.
Totally,
which I thought was kind of a neat book. Yeah,
that's great.
I'll include it as a link and send it your way.
Oh, definitely.
If I can find it.
Yeah, I've been steering clear, unfortunately, from a lot of the like normal Python documentation because Python is used on such big, complicated projects now.
Sure.
And you can do so much in so few lines of code for these big problems that I'm like, but I have very small problems, and I'm still trying to learn some of this, trying to learn how to think in a Python way because a lot of things become a lot faster if you do them more idiomatically. And so it's really hard to find the documentation. Like the real Python site has actually been a pretty good source of like, here's some basics of like how to see what is the bottom level of Python, what's going on.
Sure. Yeah. Oh, awesome. How can people follow the stuff that you do online? What's the best way?
Let's see. So I'm on Mastodon at todbot at mastodon.social. I've also got a YouTube channel that I'll link. I think it's like youtube.com/todbot that I also usually post videos. My tactic nowadays has been I make a little stupid toy thing and I'll post a GitHub gist of it. And then I'll post a YouTube video showing it in action, because it's one thing to just see the code, especially with this display stuff or with the audio stuff.
Yeah.
It's another thing to actually see it actually working and seeing how it interacts if it's got knobs or buttons, just to kind of see how it behaves. And it's really hard to get that across with just static text of the code, of the source code. And so I always, for every gist, I want to have a little video. And I'll post the video on YouTube usually, and then I'll post both the code and the YouTube onto Mastodon.
Oh, cool. Yeah, I think I've caught up on a few of those things. That's nice.
Yeah. And then once in a blue moon, I'll post onto my blog, which is todbot.com/blog. And yeah.
Okay.
We all should be blogging more, right?
Yes, absolutely. We should all own our content, not put it in somebody else's
exactly
machine or whatever. Yeah. Well, Tod, it's been so much fun talking to you. Thanks for coming on the show.
Thank you, Christopher.
I want to thank Tod Kurt for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.